Fringe theories do not start with imagination. They start at the exact point where explanations stop being operational. For example, once people begin doing actual due diligence, they start noticing things like the following. Museum collections keep the majority of their artifacts out of public view. Ancient texts survive only as copies of copies. Ancient buildings and large-scale structures lack detailed construction records and technical drawings. Individually, each of these facts is explainable. But once they start stacking, a different question appears. At what point does incompleteness become systemic? We'll come back to that. Point number 1. Epistemic gap. Every fringe theory begins with a gap. A high-density contradiction between observed complexity and simplified explanation. When we see massive structures, advanced artifacts, complex systems, but receive inferential explanations like ritual, ceremonial, or primitive technique, instead of reconstructive ones, the mind detects the mismatch. We hardly ever see full-scale reproductions carried out step by step using only the tools and constraints of the time. Too much output, too little process. The mind escalates, and that escalation is the origin point. Point number 2, engineering trigger. Now bring in technical minds. Engineers do not ask symbolic questions. They ask operational ones. What tools? What tolerances? What method? What error margin? For example, architectural conundrums like the giant monolithic stone blocks of Baalbek in Lebanon, the ultra-tight polygonal masonry of Saskahayuman in Peru, or Alakahayuk in Turkey. The extreme vertical precision and structural complexity of Cologne Cathedral, with its ribbed vaulting, flying buttresses, and load distribution system. The geometrically precise star-shaped fortifications of Elvas in Portugal, engineered directly into an elevated hillside that feels more like terraforming, and museum artifacts described as impossible for their era. Mechanical devices with miniature high-precision metal gears, clocks, automatons, armillary spheres, intricate toys, alongside ultrafine lace textiles, porcelain, and sculpture. Even today, achieving this level of precision requires highly advanced equipment, specialized technology, and by extension, entire industries, metallurgy, chemical, not accounted for in the historical narrative. Even when explanations exist, they are inferential, not reconstructive. It means that we describe how it could have been done, but rarely demonstrate it at full scale under the same constraints. That distinction changes perception. Point number 3, museum opacity. Now add access. Most artifacts are not publicly displayed. Up to 90% of museum holdings are kept in storage. Access to these collections is controlled by institutional protocols and independent examination is restricted, that limited access is often interpreted critically, with claims that requests for independent analysis are denied and results that challenge established narratives have been archived, restricted, kept hidden, or destroyed. Therefore, most items are interpreted before they are widely examined. This creates fertile ground for the emergence of fringe theories. Point number 4. Documentation gap. Another trigger. We encounter massive structures and sophisticated artifacts. We often have detailed records of who funded a project, who worked on it, how much money they were paid, and even personal biographies of the people involved. But when it comes to the actual question, how the structure was engineered and built, the documentation becomes vague, fragmentary, or indirect. Whenever we ask how exactly something was built or manufactured, the clarity drops. This creates an asymmetry. We see the result more clearly than the process. From a modern perspective, this doesn't just look incomplete, it looks uneven. According to the standard explanation, pre-industrial societies did produce technical knowledge, but it was rarely standardized, rarely fully written down, and often embedded in practice rather than explicit instruction. However, from a modern standpoint, that explanation does not fully resolve the tension, because what we observe is not just loss. We observe selective survival, and that is the exact point where interpretation begins to split. One side concludes the knowledge existed, but was never fully formalized or was lost. The other side asks, if the process is this opaque, are we certain the reconstruction is correct? Pause here mentally. We already have complexity, limited access, incomplete process. Now add one more layer, and the whole system starts to destabilize. Point number 5. Copies of copies. On closer inspection, even some of the most foundational texts of ancient and medieval history do not survive as authorial originals, but through later manuscript transmission. In other words, what we have are not the original documents written by the authors themselves, but copies of copies of copies. For example, Herodotus, Histories; Tacitus, Annals and Histories; Thucydides, History of Peloponnesian War; Livy, Ab Urbe Condita; and later works such as Bede, Ecclesiastical History of the English People or the Anglo-Saxon Chronicle, and Geoffrey of Monmouth, Historia Regum Britannia. What survives instead of authorial originals are later copies, sometimes produced centuries after the original composition. From a historical standpoint, this is normal, but structurally, it introduces a layer of mediation between the event and the record. The same pattern applies not only to historical chronicles, but also to philosophical and literary works. For example, Plato's dialogues such as Republic and Timaeus, Aristotle's works like Metaphysics, Physics, and Nicomachean Ethics. None of these survive as authorial originals. What we have are later manuscript traditions, copies preserved, compiled, and transmitted across centuries. In Aristotle's case in particular, what survives is not even a polished set of books, but largely lecture notes and compilations assembled and edited after his lifetime. Which means what we read today is mediated through layers of transmission, preservation, and editorial selection. History is not directly preserved. It is reconstructed through layers, and that layered chain of inherited reconstruction raises a truly blasphemous question. Were all recorded events and actors truly part of the original account? Or could elements have been introduced or erased along the way, shaped by context, incentive, or power? Point number 6. Mathematics friction. Now introduce a calculational contradiction. No ancient mathematical systems, before the widespread adoption of Indo-Arabic numerals in the Middle Ages, are considered to have had serious limitations. No zero, no dedicated placeholder, creating ambiguity in positional representation, difficulty of calculation. Systems like Roman numerals made multiplication and division cumbersome, often requiring tools such as the abacus. A separation between record and computation. Numerals were often used to record results, not to perform calculations themselves. And yet, ancient, grand, highly precise, intricate, and monumental structures and artifacts exist. Sophisticated Hindu temples, Greek amphitheaters, the Pantheon, the Colosseum, aqueduct systems, the Antikythera mechanism. Technically trained minds tend to pause here. How were such structures conceived and executed without modern symbolic mathematics? Today, accurate dome curvature, vault thrust control, and large-scale stone alignment are typically expressed through algebra, trigonometric notation, calculus, and positional decimal arithmetic. As always, the standard explanations are largely inferential. Geometry predates Arabic numerals. Greek mathematicians like Euclid and Archimedes operated through geometric construction rather than symbolic algebra. Engineering can be achieved using proportional methods, templates, ropes, surveying instruments, and geometric reasoning. Roman numerals were used for record keeping, while calculations were often performed on counting boards or abasi. But a logical question follows. Have these processes ever been fully reconstructed, step by step, at scale, using only that limited mathematical apparatus? If such reconstructions have been attempted, why are they not visible or systematically documented? Modern viewers expect formulas. When no formulas are visible, a capability gap is perceived. And that perception is enough to trigger alternative explanations. Point number 7. Global phenomena omitted from school program. Staffords. Now scale globally. Star-shaped fortifications. Fort Elvas in Portugal. Palma Nova in Mallorca. Fort Bourtange in Netherlands. There are over 1,000 such structures distributed across the world. And yet, they are absent from standard school curricula and rarely, if ever, appear in historical literature or cinematography. Why? The mainstream explanation of their object's function is straightforward. Artillery-era defensive structures. But upon a poorer examination of a critical mind, several objections are raised. From a military perspective, as for example 19th century general and military theorist Baron Anton Henry Jomini argues, the geometry introduces too many exposed flanks. Sharp angles squeeze out usable troop space. The global distribution appears unusually uniform. The geometric precision seems excessive relative to the stated function, and the construction scale appears difficult to reconcile with recorded population levels of the time. In some cases, entire cities appeared to be built on top of or within these structures, especially in early maps. That introduces a new suspicion. Could these be misinterpreted or repurposed structures? Point number 8. War logistics. Now, apply the same logic to warfare. Another recurrent trigger appears in critiques of historical campaigns. Even mainstream military historians, for example John Keegan, place logistics and supply capacity at the center of warfare, not just battles, tactics, or strategy. The question is simple. Could large-scale wars actually be sustained under the material conditions described? The constraints are substantial. Feeding horses required enormous quantities of fodder, often exceeding the caloric needs of the soldiers themselves. Armies depended on continuous flows of food, water, equipment, and shelter. And pre-industrial transport systems based on animal traction, river routes, and seasonal roads lacked necessary supply, stability, and predictability. Under such conditions, even a minor disruption in supply could terminate an entire campaign. When contemporary observers attempt to reconstruct these supply chains in concrete terms, calculating food volume, transport rate, animal consumption, and terrain limitations, they often encounter a point where the official narrative begins to fracture. That fracture becomes another entry point for alternative explanations. Now the multiplier. Not proven suppression, but perceived resistance. Access is limited. Publications are slow. Research is constrained. At that point, something shifts. Gaps stop looking accidental. They start looking intentional. And that transition locks the system. Now, assemble everything. Complexity, opacity, missing process, layered texts, math mismatch, scale tension, logistics strain, perceived resistance. At this point, fringe theories are not random. They are structural. Return to the question, at what point does incompleteness become systemic? There is no fixed threshold. But once enough variables align, the mind stops accepting partial explanations and starts constructing alternatives. Not necessarily to belief, but to resolve contradiction.